Have you ever imagined a football match played by robots instead of humans? I know it sounds like science fiction, but it's not that far from happening in the near future. The Atlas, from Boston Dynamics, has just taken a step no one expected this soon, learning football movements by directly watching real games. And Hyundai has already confirmed it wants to bring Atlas inside the stadiums of the 2026 FIFA World Cup, which begins in June. What looks like marketing hides a revolution in the way robots learn, and what lies behind it could radically change what you understand about artificial intelligence. Are you curious? Then watch the video all the way to the end and I'll explain. But first, subscribe to the channel and stay up to date on the latest in robotics. Atlas, one of the most advanced robots in the world, has just gained another impressive skill. It learned to play football by watching games. On the screen, the greatest moments from the World Cups play one after another. Players shooting, celebrating goals, falling on the grass, raising their arms. The robot watches attentively. Every foot position, every hip movement, every celebratory gesture. And then it turns around, heads to a training area, and begins to reproduce exactly what it just saw. The video series was named Football School, and Hyundai was direct in its presentation. That was Atlas's first contact with the sport. The company said that Atlas's journey in football has begun, and signaled that more videos are on the way. But what exactly did Atlas do in that video? Far more than kick a ball around. The robot was shown shifting its body weight to one side, swinging its leg in an arc, and guiding the ball along the ground with controlled contact. Not a clumsy kick, a soft, calculated touch, like an experienced player making a low pass. Afterward, Atlas was put through a series of quick dribbles, step movements, balance on a single support, timing and coordination adjustments. As the training progressed, the movements became more fluid, more natural, more human. At the end of a sequence, Atlas raised both arms, exactly like a player who has just scored a goal. Then, in another moment, it lowered one knee to the ground and stayed still for a few seconds, mimicking the reaction of an athlete facing an injury on the field. These gestures were not programmed in advance. They were copied directly from the World Cup videos the robot had watched minutes before. And that is what is most impressive. For decades, teaching a robot a new task meant sitting down with engineers, explicitly programming every movement, testing, correcting, testing again. A process that took months. What Boston Dynamics is demonstrating now is different. Atlas can observe and imitate, like a child who learns to kick a ball by watching other children play. The football demonstration is part of a broader strategy by Hyundai, which has been an official partner of FIFA for 27 years. In April 2026, at the New York Auto Show, the company launched the Next Starts Now campaign and confirmed it would bring Atlas and Spot, the famous four-legged robot dog also from Boston Dynamics, to the stadiums of the 2026 World Cup. The tournament begins in June and will be hosted in the United States, Canada, and Mexico. Hyundai did not reveal exactly what the robots will do during the event, but speculation points to the possibility of Atlas taking the kickoff at one of the matches. The company even named Son Heung-min, captain of the South Korean national team and one of the most popular players in the world, as global ambassador of the campaign. And in the promotional videos, he appears side by side with Atlas. For context, 3 years ago, Boston Dynamics was known primarily for viral videos of robots doing parkour and dancing to pop songs. Impressive, but without immediate practical application. What happened since then was a complete shift in strategy. Hyundai acquired the company in 2021, and since then, redirected efforts to transform Atlas into an industrial tool. A robot that not only moves with elegance, but that learns data and generalizes that learning. The football demonstration is not a detour from that strategy. It is an extension of it. Because teaching Atlas to imitate human movements from videos is exactly the type of capability a company needs if it wants to scale the use of robots in factories where processes are constantly changing and where it is not possible to reprogram everything from scratch with every modification to the production line. But how does Atlas learn to play football? What lies behind this technology will surprise you. When you watch the video of Atlas imitating football players, the first natural reaction is to think that someone programmed those movements, that an engineer spent weeks defining every angle of every joint, every weight shift, every step sequence. That is how it always was. That is how traditional robots work. Atlas works in a completely different way. Let's start with an analogy. Think about how you learned to skateboard. Nobody gave you a technical manual explaining the physics of balance, the relationship between speed and angle of inclination, the force needed with each stride. You got on, you fell, you tried again, and at some point, your body figured out on its own how to balance. Your nervous system was adjusting the responses without you needing to understand every variable involved. That is exactly how reinforcement learning works with Atlas. Instead of receiving explicit instructions, the robot practices a task repeatedly in a simulated environment. When it does something right, maintains balance, guides the ball in the correct direction, completes a fluid movement, it receives a virtual reward. When it makes a mistake, trips, loses control, falls, it receives a penalty. Over time, the robot's control system learns which actions lead to more rewards, and this process happens much faster than you might imagine. The practical consequence for you: a robot trained this way is not fragile in the face of the unexpected. It does not freeze when something goes off script because there is no script. There is a learned action policy that adapts to the environment in real time. But there is a crucial detail in the Atlas case that separates Boston Dynamics from virtually any other company in the sector. When Atlas learns to kick a ball or lift a fridge, it does not primarily do it by seeing what it is doing. It does it by feeling what the body is doing. There is a technical name for this: proprioception. Think of it this way: close your eyes right now and raise your right arm. You know where it is, even without seeing it. That is proprioception, the internal sense of position, force, and movement of one's own body. Atlas has this in the form of sensors distributed throughout its joints and structure. It feels the weight of the object it is holding. It feels the resistance of the ground. It feels when it is about to lose balance. And thanks to reinforcement learning, it has developed the ability to use that information to adjust in real time, without needing to see the ball all the time, without needing cameras at the perfect angle. The practical consequence: Atlas can operate in conditions that would bring other robots down. Uneven surfaces, poor lighting, moving objects. It does not depend on a perfectly organized world in order to function. Now, how does this learning simulation work in practice? Boston Dynamics was very transparent about this. Atlas practices each new task for literally millions of hours, but in simulation, running in parallel on hundreds of graphics processors at the same time. What would take years with a physical robot happens in weeks of computational processing. The company even stated that its goal is to train and deploy new behaviors in just one day. After the robot learns in simulation, the behavior is transferred to the physical hardware. This has a name in the field of robotics: simulation to reality transfer. And it is one of the greatest challenges in the field, because the real world has friction, vibration, noise, and inconsistencies that simulation does not perfectly capture. To help you understand better, I will use another analogy. This would be like learning to drive on a simulator and then sitting in a real car for the first time. For most people, there would be a shock. The steering wheel would feel heavier. The clutch would respond differently. The space would be different from what you had imagined. Boston Dynamics solved a large part of that problem with two engineering decisions that seem simple but are brilliant. First, Atlas has a simplified hardware design, symmetric limbs, and just two types of actuators throughout the entire body. This makes the simulation more accurate because there are fewer things to calculate. To train the robot, the company created highly realistic simulations in which it intentionally varied factors such as the weight of objects, the friction of the ground, and the robot's initial position. The goal was to make it learn to adapt to different situations rather than memorizing a single response for a single scenario. The practical result was seen in the tests with the 45-kilogram mini fridge. When Atlas was tested with loads beyond the weight for which it had been trained, reaching over 50 kilograms, it adapted without needing additional training. This is what specialists call generalization, and it is what transforms a laboratory robot into a useful tool in the real world. Now, returning to football. When Atlas observes players on the screen and then tries to reproduce the movements, it is using a related mechanism: imitation learning. Instead of Boston Dynamics explicitly programming how to kick a ball, the robot sees examples of how humans do it and tries to extract the movement patterns that allow it to reproduce that result. This is the same mechanism that, according to Boston Dynamics, can be scaled to industrial work. Instead of programming every task in a new factory, you simply show Atlas how the task is done, and it learns. This is what makes the football video moment much more than an advertising demonstration before the World Cup. For those who do not yet know Atlas and are discovering it through this video, I will summarize its technical specifications. Atlas is 1.90 meters tall and weighs 90 kilograms. When it fully extends its arms, it reaches a height of 2.3 meters. It carries two swappable battery packs and can swap each one autonomously without human intervention to maintain continuous operation. The estimated battery life is approximately 4 hours, though this figure drops significantly in tasks involving constant heavy lifting. 56 degrees of freedom. That is the number of independent axes of movement in Atlas's body. For comparison, an adult human being has around 244 joints, but most of them have quite limited mobility in everyday life. Atlas has joints with 360-degree rotation at strategic points such as the hip, waist, and neck, which means it can perform movements that are physically impossible for any human being. The certified payload capacity Atlas can carry is 50 kilograms, the equivalent of 2 stacks of bricks or a large full travel suitcase. The sustained capacity for continuous tasks is 30 kilograms. The most surprising thing is that when Boston Dynamics engineers tested Atlas with loads above the limit for which it had been trained, going beyond 50 kilograms in internal tests, the robot did not freeze, did not fall, did not need reprogramming. It simply adapted, on its own, in real time. This is what specialists call zero-shot simulation to reality transfer, a behavior learned entirely in simulation that, when it encounters a new situation in the physical world, generalizes the solution without needing additional training. No other industrial humanoid robot has demonstrated this publicly with that level of documented technical detail. Atlas can operate at temperatures from -20 degrees to 40 degrees. It has 360-degree cameras, laser detection system, color and stereo cameras, depth sensors, and tactile feedback in the hands, fingers and palms with touch sensors capable of adjusting gripping force depending on the object. It detects approaching people and automatically pauses or adjusts its movements. Atlas's hands scale to the level of dexterous manipulation. The fingers have sensors that identify resistance and surface, which allows it to hold fragile objects without breaking them and heavy objects without dropping them. The robot is not yet capable of making complex tactical decisions in football, for example. It reproduces movements it learned by imitation, but does not understand the game. It does not read the position of opponents, does not decide where to pass, does not react to completely new situations within a strategic context. Real football involves high-speed decision-making in an unpredictable environment, and that is well beyond what Atlas has been tested to do. In industrial environments, the situation is different and more promising. But even there, Boston Dynamics engineers admitted that tasks involving very fine manipulation in extremely congested spaces are still challenging. Not because the robot does not have enough strength or sensors, but because the learned action policy needs more data to generalize those specific scenarios. Regarding walking speed, Boston Dynamics did not disclose an official figure for the 2026 production model, but public demonstrations show Atlas moving with agility comparable to a human walking at an accelerated pace. In gymnastics demonstrations, such as the handstand, Atlas performs sequences of acrobatics without any external help. Although Atlas is still taking its first steps with a ball at its feet, it no longer seems so absurd to imagine that, in a few years, we will see football matches played by robots. And you? What did you think of this new skill of Atlas? Would you put it on your team? Or do you believe robots will never come close to human talent? Leave your answer in the comments. If you liked the video, give it a like and subscribe to the channel. That way, you will always receive notifications of new videos. See you next time!